Thank you so much, everyone, for joining. Um, my name is Paulius. I am the Scientific Director of the Paris Institute for Advanced Study, and welcome to another Paris IAS Ideas talk. So we are the Paris Institute for Advanced Study. We are a research institution in Paris that resembles 12 of the major universities, plus the CNRS, the City of Paris, and a few other partners. We are an interdisciplinary center in social sciences and humanities, and our main role is to create links and build bridges between international research and the local research ecosystem. Today, we will have 3 presentations. This is part of our Paris IAS Ideas speaker series, which features the fellows that come to Paris on a new program that we have, which is a 1-month writing residence for fellows to work on an idea or concept that is important to their work, but they haven't had the opportunity until now to write it in a single paper that will be published at the end of their stay in open access for a wide audience and so on. And today we have 3 great speakers. At 2 p.m., we will start by Professor James Hollan talk on networks of networks, collaboratory to address the grand challenges of the future of information work at the human technology frontier. And I will introduce the other 2 speakers as we go along. The talk, as in previous occasions, will be divided in these 3 parts. We will have 20 minutes of the main talk, then around 30 minutes for questions and answers, and then we will have a 10-minute recess, and we will go to the next speaker for today. So that will be around 3 p.m. Paris time, Central European time. And with that, I am very happy to introduce Professor James Hollan. He is a distinguished professor of cognitive science and computer science and engineering at the University of Californie, San Diego. He was a fellow at our institute in 2021-2022. And he's also the founding co-director of the UCSD Design Lab and the HCI and Distributed Cognition Lab. So thank you so much, Professor Hollan, for being with us, and please go ahead.
So I'm Jim Hollan, and I'm gonna. No, I'm not. I have a thing hanging over my screen but I can look at the big screen. So I'm going to tell you a little bit. I'm going to try to take 20 minutes, and maybe it'll run a little bit over. But if it runs a little bit over into questions, it's because I'm answering a question that Sadi would have answered had he been here. So let me get going. The project is that I'm going to do while I'm here is to 2 things. One is to write a proposal for the National Science Foundation about a collaboration between laboratories in the US and laboratories in Europe. And then I'm also going to write a more popular version of that I see as sort of being a manifesto for what kind of human-computer interaction might be like in the future. And so let me get going. And I want to sort of start by talking about some maybe weird-sounding concepts that are we're having yeah, I'm just live with it. I can look up there. Yeah, I could just look up there. So some weird sounding concepts that are peculiar to this, and I think maybe starting with those sort of simple ideas will help me talk about the bigger ideas that I have. And so I'm going to talk a little bit about what I mean by active information. Most of the information in the world is static. It's words on pages of paper. It's words in browsers that we read. And I'm very interested in making information more active. And then an even weirder idea is a notion of cognitive physics for information. So if we have sort of active information, it needs to have a physics, how it behaves. And in the world here, when I hold up this thing and drop it, we all know what would happen to my phone. It would crash to the desktop here in front of me. And that's sort of a physics of the real world. But in these kind of virtual worlds, we have the opportunity to build our own physics of how things behave, what they do. And in my view, it should be a cognitively inspired physics. It should be inspired by what we know about cognition and people. And so let me give you just a really simple, super simple example. When I was putting together this talk, I was in Keynote, which is like PowerPoint for Macs. Here, let me get rid of this just 1 minute. Let me hide video panel. And okay. So when I was in Keynote, putting together these slides, one of the things I noticed is sort of this really nice physics as I move this block of text. When it aligns with this region, it draws this line up the screen. And I can move that text anywhere I want, but the sort of physics of this world is such that it gives me feedback about where it is. So it makes it very easy to do alignment. Now that's being done by the application in this case. But imagine that information itself was imbued with behavior, that it could do things. It could sort of present itself in an appropriate way for the context that you're in, kind of thing. So it's a very simple example. Now suddenly I don't have control over. So here's another example. This is some work by Wendy McKay. And Wendy McKay is here in Paris, and her husband lead a really interesting HCI group that's sort of split between University of Paris-Saclay and INRIA. And what they're interested in is a lot of our work now is done on tablets with pens. And let me actually go back and start this over again. Wanted to do a help command, and the gesture for that is to draw a question mark. And you're learning all of these gestures, and in Wendy's system, Octo-Hocus, it sort of shows you, if you slow down, it sort of shows you all of the possible commands that you could be doing. So if I do it really fast, it doesn't show me anything. So it's sort of very much in sort of supporting people. So it's sort of a physics for learning this kind of information, this kind of gestures. So here's a command to save things, which is an S. And you can sort of see it drawing through there. Okay, so let me give you a little bit more complex example. This is my colleague Haijun Shi at the University of California, San Diego. And Haijun is one of the co-PIs on this proposal that I'm working on. And one of the things is Hygiene is built as a system called writ large. And so this, to me, is sort of an example of a sort of a primitive, what we would sort of say, information space that someone's interacting with. And the information in that space has behaviors and do things. So now I need to play sound. So we have
creativity support tool for electronic whiteboards and tablets using pen plus touch interaction. Its unique contribution is a continuous free-flowing style of interaction through unification of scope, action, and zoom. To indicate scope, the content creator just frames part of the canvas with their non-preferred hand. This evokes the zoom catcher, which illuminates an area for selection in an extremely lightweight manner. The user can then act in the strokes, such as to recognize, but only what areas the user wants and only when the user chooses to do so. The zoom catcher reveals itself by piggybacking on a familiar gesture, pinch to zoom, and as a result, it's largely self-explanatory. The user can grab things right away, or adjust the angle, cast it in different directions, and fine-tune its extent if necessary. Its coexistence with zoom allows objects, large and small, to be brought within reach. By making indication of scope fast, simple, and clean, the zoom catcher sets the stage for action. Commands appear at hand, locally, alongside the selection. For example, the user can go up one semantic level and recognize as well as unrecognize ink, or even drop down a level and work with the stroke points. Moves shift between flexible and reversible representations. Dropping images to the pixel level allows blending with the finger, rubbing away with the eraser, or cutting parts of the image away with the pen. These flexible representations comprise 4 axes of movement in the menus. In addition to semantic levels, there are structural levels, moving between free-form layout and organized grids. Temporal levels, which allow select strokes to be locally unstuck in time, as well as social levels, which allow pulling in inspirations from others by searching the web, as well as sharing between tablet and whiteboard.
Okay, so that's sort of a simple example. And again, what I would emphasize is this notion of physics for information. Again, in that example, this is an application that's doing all of that. But what I want you to imagine is that information itself had behaviors like this, that we could, as it would sort of present itself in context-appropriate ways or to deal with that. I'm not going to really play this next video, but I'll point you to it. And at the beginning of the week, OpenAI, which is a company that did ChatGPT, had their first Developers Day, and they're showing this sort of revealing sort of the next stages of development in that. And this is Sam Altman, who's the CEO of OpenAI. And one of the things I was going to show, but I'll just point you to the video of it, is how he shows building a ChatGPT-like entity that's sort of based upon a set of information that you can provide, and doing that all with natural language. So any of us with no programming ability could be able to do that kind of development effort to build this special ChatGPT. The example he uses is building one to give advice to folks asking questions about startups. So he downloads a bunch of his papers giving advice, and then ChatGPT uses that to answer questions. So the next thing would have started a video, but I'm going to skip over it. But if you go just search for OpenAI and see their development platform, you can watch that video. And I think it characterizes for me what a lot of programming might be like in the future, where people are empowered just by natural language to be able to build things that support them in their efforts. So anyway, so I want to, I hope someone's keeping touch of time. My clock didn't start, but I want to tell you a little story about this project. And I think science is always about stories. I love this quote of Peter Medawar. Peter was a Nobel laureate. He talks about science begins as a story about a possible world, a story which we invent and criticize and modify as we go along. So it ends up being, as nearly as we can make it, a story about real life. And I think that really describes a lot of science, that we're trying to bring scientific understanding to the world. And a lot of physics is surely that way. That, you know, what we're trying to do is to understand the physical world at all kinds of different levels. But one of the really nice things about my area of research is that we can make some of our stories true by writing code and building systems. So in a lot of ways, we have advantages over the physicists and the astronomers who are sort of stuck just trying to explain the current world. Not that that's easy at all. But we can sort of create worlds. We can build systems that do things. We can build things like Haijun did in writ large that creates a new kind of environment for dealing with information. And surely the biologists are also starting to do this. I mean, all of us sitting around here where our bodies have been hacked, been programmed to build antibodies and things to viruses to protect us. And so they're sort of moving into this world of writing code and building systems like that. And I think especially important are appreciating the kinds of stories we tell ourselves to convince ourselves to put the time and energy into a new research project. And often we do that long before we have really any data about it. And I think in writing a proposal, one is doing that kind of thing. One is trying to build a story in which we try to convince others to invest in our research. So let me tell you a little bit more about this story of this proposal that I'm working on. I'm not at all sure where the story really begins, and I surely don't have time to tell the whole thing in any case. But I've always been interested in dynamic interactive representations, the kinds of examples that I've been doing, where suddenly information can have behaviors and do things and change its form. It's what I sort of now term that what I'm really interested in is how we can improve thinking with computers. And I didn't really realize that what I was interested in until a few years. I got this big award, a lifetime research award by the Association of Computing Machinery. And one of the things I did as part of that award was to give an 80-minute lecture that was supposed to reflect back upon all the work I'd done during my career. And it was really the first time I'd ever really reflected back upon all of the work I had done. And one of the things that seemed to be very clear to me is that I'd always been interested in thinking with computers, how we can build environments where the computation can aid us and collaborate with us from that. And a more recent chapter of this proposal really began here at the Institute. As it was said, I was on sabbatical for a year here. An incredibly pleasant year, really wonderful opportunity to interact daily with folks in very different disciplines. And at that time, I had just started a research collaboration on this notion of active information and cognitive physics that I tried to paint a bit of a picture for. And I had sort of what was a pretty international group of folks in the US at MIT, at Stanford, folks here in Paris at Saclay, and at INRIA, folks in Denmark, and all of the folks are folks that I've had long-term relationships with. So Wendy McKay, who I showed you that little example of, Wendy was actually an undergraduate at University of California, San Diego, before she went on and got a PhD at MIT. My colleague at MIT, Arvind Satyarian, was also an undergraduate, did an honors thesis with me. I've spent a lot of time with all of these folks, and I think one of the things that you don't realize is how much trust is involved in collaboration and knowing people and trusting them. So anyway, we had this, I thought, pretty exciting group. It seemed to match the needs of a program at the National Science Foundation called ExcelNet. And the purpose of that was to support interaction between research groups in the US and research groups outside of the US. And it seemed like that's exactly what we had. And so I wrote a proposal when I was here the last time. And unfortunately, it wasn't funded. We got really positive reviews about the science of the project. But they said that we were not really a network of networks. And that was really true. It was really a very close network of folks who knew each other, although we were distributed across the world. And so I'm rewriting, in effect, that proposal while I'm here. So we're going to be submitting another ExcelNet proposal. And now NSF has been much more explicit about the proposal being about networks of networks. So they want to fund collaborations between sets of networks. And there have to be at least 3 networks involved. And so in our proposal, we're going to be talking about this original network that was the substance of the first proposal. And then really fortunately for me and for the proposal, there's been a new, last month, there was a big new funding for this ensemble network in France, which is focused on the future of digital collaboration, kind of thing that we're doing right now. And as anytime you've been involved in it, you know there's always issues of it, and it doesn't work the way it possibly best could. And so that's going to be a second network in the proposal. And then one of the people who was involved in the first proposal is Jamie Tavine. And Jamie is the chief scientist at Microsoft. And Microsoft has a large effort in what they term the future of work. And so we're sort of putting together those 3 networks. And so since it's networks, you have to draw network kind of diagrams. But this is our view of the future of what we're calling collaboratory for design of information work. And it will involve these 3 networks that I've mentioned, but also involved the Institute here and a number of folks on an advisory panel for that. How am I doing for time? Anyone?
If you could wrap up soon, that would be great.
I couldn't understand a word you said.
We are, yes, almost out of time in the presentation, but yeah.
Okay, well, I will, maybe this would be a good place to end it. And maybe just to summarize, I think the big ideas for me are a sort of new view of information, information that's active and dynamic, that has the history of its interaction encapsulated in it. And I think what we're missing now is an intellectual place to work. Our intellectual work now is spread over, Google Drive and every other kind of file system on this computer, some on our phones. everything is sort of, all of the companies are trying to build sort of gardens with very high walls around them that you're in one there. It makes it very hard to move information from one application to another, or from one organization to another. And what we envision is putting together a really place to think, an intellectual workplace. And the criteria of it is going to be very visual, because we're very visual creatures. That's what we're really good at. So, and it's going to be supportive of efforts that are longer duration kind of things. All important efforts extend over time. And we face all kinds of problems of reestablishing context when we get back to that paper after vacation that we're working on, or that program we're working on. So we want to build an environment that's supportive of that kind of effort. Anyway, I'm be glad to share writings about the proposal and things with folks, and I look forward for this sort of wonderful opportunity to be here and have some time to actually think that one rarely has as a professor with too many responsibilities, and the urgent always sort of conspiring to drive out the important. So I'm really appreciative of this opportunity to be here in this sort of wonderful site in this wonderful city.
Great, thank you so much. We are very happy to have you here as well. Right, so we have some minutes for questions. Are there any questions? Yes, Patricia.
Yeah, so I had one question, and the question regards why is it that you say that it's new, the fact that you're going to employ information in this particular interactive way? Couldn't one say, for instance, that DNA constitutes a form of information that has these kind of properties? So I would like you to explain a little bit more why it is new. Thank you.
Well, in some sense, it's probably not novel and completely new. Everything builds upon things of the past. I think what is new about it is a movement away from individual applications, and not a total move away from it. We sort of view this information space as being a separate space that's linked in to the existing information space. It's a place where can accrue the history of your interaction with information and make that available to you. It can record all of the things that you do with the information. One of the examples that we've been working on is when you get back to, say you've been on vacation, you go back to working on a paper or a program or something you're working on, and it's very hard to get back in the context of that. Could we provide you with something that would help you reestablish that context? Something the equivalent of on a series on TV, say Breaking Bad or some old series like that. At the beginning, they often have some very short segment that's a bunch of cuts and fades between various information that happened in the past. And it brings back what was going on. Oh yeah, the drug deal was going down in Mexico and they'd just gone to there. Could we have the equivalent of that for your information activities? So the last time you were working on this paper, and it could show you at different levels of detail a summary of that, the kind of things that Saudi has shown with first-person video that can really re-invoke context kind of things. And so it's not novel in the sense of not wanting to build upon what we know about people, but to try to do that in a way where the information itself starts to carry this history and this things of activity. It's going to be very dependent upon recognizing context and very hard representational issues of how to represent this kind of information at multiple levels of detail. And I don't know if that gets right at your question, but it's my attempt.
Thank you.
Great. Thank you very much. Next, we have Michael.
Great. Thanks very much for the really interesting work that you're doing. So I have a basic question. It's more of a theoretical question. I was hoping that you could explain the difference between a network and a network of networks. It seems like a network of networks could just be redescribed as a single network.
Right.
Is it like a multi-network where you have different kinds of edges and different kinds of nodes, and then they're linked together with different kinds of edges? Or, is the math different? Is it more of a kind of a way of thinking that is more kind of qualitative? So yeah, that was my question.
I think it's more a buzzword of the National Science Foundation than anything else. Sorry, as my time is up. I don't think of it very much in terms of the graph theoretical kind of notions. I actually spent my whole undergraduate career working on the four-color conjecture, and got very involved in graph theory and things like that. So I don't think it's technical in the sense of graphs. What they're very interested in is at least three sort of established collaborative research endeavors that have been going on, and could we fund interaction between those networks that would allow them to do things that they would never have done if they were still isolated in their individual networks. So a big part of our proposal is for funds for people to move between these various networks, graduate students, postdocs, faculty, and the argument is that really people are the best vehicle for carrying ideas. And I think that NSF wants to encourage that kind of collaboration that probably wouldn't happen otherwise if there weren't this funding for cross-network kind of cross-pollination and stuff. So I think it's not a technical thing, and surely every network of networks could be described as a network. And we thought we sort of qualified before when it was just sort of our network, because there were all kinds of labs involved in Canada and across the US and in France and in Denmark. We sort of viewed ourselves as being a network of networks, but it didn't meet the requirements of the way NSF is thinking about this. And I can surely see some positive motivations for trying to encourage this kind of cross-network interactions that surely happen at conferences and at meetings and stuff, but don't have an opportunity to folks to move from one network to another network for an extended period of time. So we're envisioning, summer kinds of things where students would move around these various networks instead of going off to a company for the summer for an internship. Groups of students might move to another laboratory and learn about the culture and the things of that laboratory. And I think could be very conducive to this kind of interdisciplinary kinds of things where, every problem now could benefit from interdisciplinary kinds of perspectives.
Got it. Thanks.
Sure.
Great. Thank you. And next we have Nikita.
Hi, everyone. Thanks a lot for the talk. I just wanted to maybe shed some light and add some clarity to the discussion about networks of networks here. I don't know what's the scientific foundation's opinion of that. but it's been introduced in complex network science. We have recently introduced it in social networks. The paper is called Analyzing Networks of Networks, led by Johan Koskinen, published in early this year. And we can, of course, think about networks of networks in the real world. You can think about organizations, which include people who are connected to each other, but then organizations themselves have, for instance, collaboration ties, which kind of unite these groups of people included in organizations with something like, for instance, you can think about hyperedges or line graphs. When you have higher order kind of connections between groups of actors who are connected with lower order connections. So that would be then the network of network. I don't know how it relates to, again, to the Foundation's perspective on that, just to add my 5 cents here.
Yeah, I mean, I totally agree. I mean, I think these kind of social networks are good examples of that. And I think one of the strengths of our proposal and the effort is that we already have close social ties between the various networks. And as I said earlier, I think oftentimes research interactions are so dependent upon building up trust. And I think the existence already of close social ties between members of these various networks will be really advantageous to collaboration. I've been involved in a lot of large NSF projects where usually they're a 3-year duration, and you propose this kind of pretty extensive collaboration. And in almost all cases that I've been involved in, it's only at the end of the 3rd year that you're really in a position to collaborate, where you know enough about what other people care about and what they've been doing to be able to build a kind of really a collaborative effort. And so one of the things I want to try to emphasize in the proposal is that there's this, maybe this spanning tree underlying this network of networks that has these existing ties that will aid the network's collaboration across these barriers. When it's just all new people and no one knows each other, I think it's very, very hard to collaborate. And so I sort of see myself and others involved in the network as being a kind of glue to hold things together and to aid the collaborations. But collaboration is always hard and challenging, and I think particularly hard when it's cross-cultural in that. And I think one of the big advantages that we're going to try to highlight in the proposal is just how beneficial it is for young graduate students or postdocs to have time in another culture. Even if the culture of the research is similar, there's so many other aspects that I think one benefits from. And I know that the year I spent here at the Institute with folks who were in radically different areas from me, how much I benefited from that, and built relationships and friendships and things out of that.
Wonderful, thank you. We have 5 minutes in case there are other questions. All right, if there aren't, so thank you so much, Professor Hollan. Thank you so much, everyone. So we'll take 15 minutes recess, sorry. In 15 minutes at 3 p.m. Central European Time, we will meet again for, I will share my screen now, for Professor Angelo Torre talk entitled Commons as Local Institutions. So yes, see you here in 14 minutes now. Thank you so much again.